All right, let's get started on the third page. So the third page has common functions and transformations, and we have to sketch the graphs, so they're a little bit accurate. And then at the bottom there we have composite functions and then also operations with functions. Okay, so let's start off with the common functions. Let's just do all of those at once. It's just the most basic form of, the functions that you see here, the ones that we know. The common functions are just a linear equation, y equals x, quadratic function, x squared, cubic function, x to the third, and it can keep going on like that, x to the fourth, x to the fifth, and so on. Absolute value of x, and then also the square root of x, the cube root of x, and so on. There's a ton of them. So we just look for the function that's happening to x, in its most basic format. That's the common function. Another name for the common function, if you see it, is parent function. So just know that those mean the same thing, parent function, common function. Anyways, if this is x squared minus 6, x squared is our common function. Let's just do all these at once. Negative x squared minus 3, that's also x squared for the common function. Quantity x minus 1 to the third plus 7, so that's x to the third, or the cubic expression. Negative square root of x plus 4 minus 3, so square root of x would be our common function. Square root of x again for e. And then x squared for f. And g looks like it's going to be the absolute value. And absolute value again for h. All right, so there's all of our common functions. Let's just get those out of the way real quick. Next, we need to list off the transformations. So the transformations, if you remember, look something like this. Y is equal to, and then we take a function, f of x, whatever it is, whether it's any of these parent functions. And if we have x inside of the function, if it's adding or subtracting some value h, it's either going to be moving to the left or to the right. If it's adding some number, then it's going to be moving to the left. If it's subtracting some number, it's moving to the right. If we're adding or subtracting outside the parentheses, outside the function, then that means that we're going to be moving the graph up or down. If we're adding some number outside of the function, then it's moving up. If we're subtracting outside of the function, it's moving down. And then the last thing that we have is the letter a. So with a, if a is negative, then that means that it's going to be a reflection over the x-axis. If a is greater than 1, then that means that we have something called a vertical shift. If a is less than 1 but greater than 0, then it's going to be a vertical compression, and I have a factor of a for both of those. So let's just do these one at a time and see what we've got here. Let's start with the inside part. So inside the function, if we're adding or subtracting, it's moving to the left or to the right. If it's adding, it's moving to the left. If it's subtracting, it's moving to the right. So let's see if we have any that are inside of the function. So inside the parentheses, essentially. So let's see here. Yep, we have inside the parentheses here, x minus 1. Since it's subtracting 1, it's moving to the right by 1. There's one transformation. And then looks like we've got another thing going on inside of the function, inside the square root here. It's x plus 4. And since we're adding, we're going to be moving to the left. So it moves to the left by 4. And then nothing here, nothing here, nothing here, nothing here. So that's all the left-right stuff that we have. All right, now let's see if we have any addition or subtraction outside of the function. So if it's adding, then it's moving the whole graph up. If it's subtracting, it's moving the whole graph down. So it looks like we're moving, let's see, it's subtracting 6 outside of the function. So this is moving down, a shift of down 6. This one is subtracting 3 outside the function, so we're moving down 3. This one's adding 7 outside the function, so we're going to move it up 7. This one's subtracting 3 outside the function, so down 3. This one is subtracting 5 outside the function, so down 5. This one is adding 3 outside the function, so up 3. This one is adding 7 outside the function, so up 7. And this one is adding 9 outside the function, so up 9. So that was a lot of up and down motion there. Now we look at the a value, so the number that's multiplying on the function itself. If that number is negative, then that means that we're going to have a reflection over the x-axis. So there's no negative on the x squared here, but there is one over here. So that means we have a reflection over the x-axis. No negative outside there, negative outside here. So that means it's again going to be a reflection over the x-axis. No negative out front here. -2, so that means that we do have a negative number out front, so another reflection over the x-axis. No negative in front of the absolute value, but there is a negative in front of the absolute value here, so that is another reflection over the x-axis. So the next thing we do is check to see the actual a value that's multiplying out front itself. If it's just 1, then the graph doesn't do any vertical shifting, vertical stretching or vertical compressions. But if the a value, the absolute value of a, is greater than 1, then it's a vertical stretch. So let's look for a vertical stretch. There's nothing multiplying out in front of any of these examples or these ones, but there is a 2 multiplying out front there. So if our a value is greater than 1, then that means we have something called a vertical stretch, and it's of a factor of 2 in this case. If the a value is between 0 and 1, so if it's less than 1, like 0.75 or 0.5 or 1/3, just any fraction or decimal value that's less than 1 but greater than 0, then that means that we have a vertical compression. And on H, we have that 1/2 over there. 1/2 is between 0 and 1, so that means that we have a vertical compression of 1/2. Some like to write that it's a factor of 2, because it's like dividing by 2, but I like to just write 1/2 on there. It really doesn't mean much of a difference. Okay, now we actually graph these out. Now on your test, obviously the graphs will be much larger so you can get more accurate. So what I'm going to do is just graph all of these out individually on my graphing calculator just to see how they look. And then you can translate that on your graph when you're actually taking the test. So the first function is, let's see here, x squared minus 6. So x squared minus 6, and then graph it out. And remember that you can always go to your table, so second and then graph, and find some coordinates to graph out to make it a little bit more accurate. That's always pretty helpful. Let's go to C now. So we do parentheses x minus 1 end parentheses, and then to the third power, so to the power of 3, and then plus 7. So plus 7 and graph. So there's another graph for us, and once again you can go to the table and just get a couple coordinates, graph them out. Obviously, like if we have -4, -118, you're not gonna be able to graph that, but a couple of these coordinates could work out on a graph pretty easily. All right, and then E, looks like we've got the square root, so square root, y is equal to the square root of, let's mess it up, there we go, square root of x, and then outside the square root minus 5. Make sure that you press the right button if you have one of these TI-83 plus CEs, because otherwise, if you don't press right, you'll get x minus 5 inside of the square root. So be careful of that, and make sure to press the button to get out of the function. So there we go, minus 5. And then graph that one out. And it's a square root function that's been moved down 5, just like what we anticipated with the transformation. Then just graph it out. You can go to the table and graph out a couple of coordinates to work out, like 0, -5, 1, -4, 4, -3, etc. For the G, for letter G, we've got 7 plus, and then absolute value. Absolute value, if you hit the math button and then hit right, you'll get the absolute value, and it's just the absolute value of x. There we go. And then hit graph on that one. So it's just the absolute value has been moved up 7, so nothing crazy there. All right, and then do the other ones. So -x squared, so negative, and then x to the second power. Make sure you press the negative button down here, not the minus symbol, negative for negative variables. And then squared minus 3, graph. And there's our graph. It's been reflected over the x-axis, so facing downwards, and then shifted down 3, just like what our transformations predicted. Okay, the next one we've got is negative, so negative symbol again, square root of x plus 4 in the radical, and then outside the radical minus 3. There's the graph of that, so it's an upside down, so reflected square root, and it's been moved to the left 4 and also down 3. All right, so next one we've got is -2x to the second power plus 3. Graph it out. There we go, and then you go to the table, get some nice accurate coordinates there, to graph out. And then the last function, h, is going to be negative, and then 1/2, so 1/2, and then parentheses, or absolute value, sorry, so math, and then right, and then absolute value of just regular old x, and then outside of that plus 9. So we hit graph on there, there's our absolute value, and it's shifted 9 units up, reflected, over the x-axis, so it's facing downwards, and then the compression makes it much wider, like that. Okay. So now let's work on these other problems, number 15, all these transformation problems that have to do with these three functions, f, g, and h. So in this problem, reading the notation is really, really important. It's important to note that this is how you put together the function. You take the f function, subtract the g function. What this part says is not to multiply by 4 afterwards, but it actually says to plug in 4. It's just function notation. Similarly, this one says that we're taking the f function, multiplying by the h function, then plugging in 1, not multiplying by 1, plugging in 1. This one says we're taking the composition of the h function with the g function put inside of it, and then we're plugging in 7. For the bottom ones, since these x's are here, we're not multiplying by x, we're just leaving them in terms of x. We don't have to plug anything in or multiply anything out, nothing like that. Okay, so for each of these expressions, we do the functions, and then we find their domains, and then plug in numbers where we need to plug in numbers. So this one says the f function minus the g function. So we take the f function, 3 minus 2x, and subtract away the g function. In this case, it's just the square root of x. Okay, so once you do that simple operation, stop and check and see if there's any domain restrictions. Since we have a square root here, that means that this x value, for example, has to be greater than or equal to 0. That's our domain for this function. But now that we've done that domain restriction, let's go ahead and plug in 4, because there's no other combining like terms or anything that we need to do here. So plug in 4 for x, we get 3 minus 2 times 4 minus the square root of 4. So that's going to be 3 minus 8 minus 2. 3 minus 8 is negative 5, and negative 5 minus 2 gives me my answer, which is negative 7. For this one, if we're multiplying two functions together, f times h, so the f function is 3 minus 2x, the h function is 3x squared plus 2. So there's no division by x, there's no square roots of x, anything like that. So that means that our domain is going to be all real numbers for this function. And now let's plug in 1, so we get 3 minus 2 times 1, and then 3 times 1 squared plus 2. So for this one we just get 1, for this one we get 5. 5 times 1 is 5. Easy enough. For the composite function, we're taking the g function and using that as an input into the h function. So the h function looks like this. So we do 3 times the input, whatever the x value is, squared, plus 2. And in this case, the x value is the g function itself, so the square root of x. So here's where we do our domains. So the square root of x tells us that x it has to be positive or 0, so greater than or equal to 0. That's our domain. Now we can just simply plug in 7, so 3 times parentheses square root of 7 squared plus 2. Square root of 7 squared is 7, so 3 times 7 is 21, and 21 plus 2 gives us our answer, 23. Okay, next. So this says to take the f function, divide by the h function. And then this x just means just leave it alone after that. You don't multiply by x or anything crazy like that. It just wants the functions as it is. So the f function is 3 minus 2x. The h function is 3x squared plus 2. So there's our function. We can't reduce it any further or anything crazy like that. So it just is what it is. Now we state the domain. So this is a rational function, and domains for rational functions ask you to take the bottom function, the denominator function, 3x squared plus 2 in this case, and we just can't make that, we just can't allow that to be equal to 0, because that would be division by 0 and a break a math law. So what we need to do is now get x by itself. We subtract 2 from both sides. 3x squared cannot be equal to negative 2. Divide by 3, x squared cannot be equal to negative 2/3. And we can actually stop right there, because there's no way, no x values in the real numbers that we can plug into x to get a negative number, because any number squared is going to give you a positive number. So since this isn't possible, that means that we can use any x value in the domain. So any x value in the denominator or in the numerator, and we're good to go. All right, so this says that we're taking the g function and plugging in the f function. So the g function's template looks like this, the square root of something. And that something that we're plugging in is going to be the entirety of the f function right here, 3 minus 2x. So again, there's nothing that we can do to simplify this any further, so this just is our function right here. And what I mean by simplifying is, like, if we can factor, if we can distribute stuff or whatever, that would help us to simplify the expression, but there's nothing that we can do here, so we just leave it alone. As for the domain, since this is under a square root, we need to make sure that that function in the square root, 3 minus 2x, is positive or 0, so greater than or equal to 0. Now, simply solving for x, we just add 2x to both sides. 3 is greater than or equal to 2x. Divide by 2, x is less than or equal to 3 over 2. So there's our domain for that one. All right, now we've got our composite function. We take the h function, which is 3x squared plus 2. So 3 times our input value squared, and then plus 2. And we plug in the g function, so square root of x. We actually just did that one previously in part C, but now we're just writing out the function itself. So once again, we have a domain restriction just like in part C, so x has to be greater than or equal to 0. But this is pretty fun because we can distribute, we can evaluate it a little bit further. So if we have this square root and this square, they cancel out mathematically because they're inverse operations of one another. So we just simply get 3x plus 2, and that's our function, 3 times x plus 2, and there's our domain. X has to be greater than or equal to 0. All right, so that's the third page. Just make sure that if you have any questions on any of this stuff to contact your teacher and get some help, or get some help somewhere else. Call a friend, get a study group going, whatever. All right, that's it.